Hello, it's Mr. Srikanth Palm here, and here's your video on how to estimate complex calculations. Now, you should have completed task 130 on Hegarty, so rounding to significant figures should be no problem to you. And just to double check that, we're just going to have a look at some significant figures stuff first. So, pause the video and have a go at this question, where I'd like you to just tell me what the first, second and third significant figure of each of the following numbers are. So pause the video and have a go at that. Okay, hopefully you've attempted that and have some answers. So in the first number, so 3,456, the first significant figure is the 3, and that 3 represents 3,000. The second significant figure is the 4, and the 4 represents 400, and really we would only consider the first and the second together. There's no point considering about the 4 if we forget about the 3. And the third significant figure is the 5, which represents 50, but as with above, 3,450 really. And then so just to clarify, the first significant figure is the 3, the second significant figure is the 4, the third significant figure is the 5. On the second number, because we've got this preceding 0, this 0 isn't significant, so the 7 here is our first significant figure. So that would be 0.7. The second significant figure is the second 0, because once you've got to a number that's significant, everything after that is significant. Once you know that this 7 is significant in the 10th column, knowing that there are 0 100ths is actually very important information and does tell you something. The zeros at the start, as many zeros as you want at the start, don't tell you very much, but this 0 now does tell us stuff. So we know that to two significant figures it would be 0.70 as the second one. Obviously it wouldn't round to this as two significant figures because the 6 would cause us to round up. And then the third significant figure gets us thinking about the thousandths column, and so the third significant figure is the 6. Just be careful here, I'm not rounding these values. If I rounded, for example, 3,456 to three significant figures, I would get 3,460, not 3,450. I'm just identifying that this 5 was the third significant figure, this 4 was the second significant figure, this 3 was the first significant figure, and on the second number, the 7 is the first significant figure, the 0 here is the second significant figure, and the 6 here is the third significant figure. Okay, how can we use this to estimate calculations? Well, from what we've done on this page, you should now also know how to round these numbers. If I were to round 3,456, 3,000 would be at one end of my number line, 4,000 would be at the other end, and 3,456 would be a little bit lower than halfway, so it would round to 3,000. If I was rounding to two significant figures, then I'd have 3,400 and 3,500. 3,450 would be in the middle. The number would be just above that, so it'd be nearer to 3,500, so I'd round to 3,500, etc. Now, don't worry about the second and third significant figures. The most important one here is the first significant figure and rounding to one significant figure, and that's what we're going to do. So here's a question. I'm going to do this question, so this is an I do. First of all, I'm going to round each of the values in the question to one significant figure. So first of all, I need to establish what the first significant figure is. First significant figure on the first number is the 1 in front of the 17, so that's the 10. On the second number, it's the 3. On the third number, it's the 8. So my number lines when I'm rounding are 10 to 20, 15's halfway in between, and my number's somewhere over here, so I'm going to be using 20. My second number was 3.764, so that means I need 3 here, 4 here, 3.5 is in the middle, 3.764 is a little bit higher than that, it's about there. So again, I'm going to use 4. And for the last one, 0.8, 0.9, in between is 0.85, 0.847 is a bit lower than that, so I'm going to be using 0.8. So instead of the calculation, now here's a very common error. Students often fail to read the question. The question here is asking me to estimate. If I'm being asked to estimate, they do not want me to work these calculations out exactly. Multiplying 17.351 by 3.764 is hard work. It's very straightforward, you can do it in the grid method, but it's hard work and it would take a long time. To do an estimate, we just need to use rounded numbers, and we're going to use roundings to one significant figure. So our estimate is going to use 20 multiplied by 4 divided by 0.8. I'm going to write approximately equal to. So this similar to an equal sign, but with a squiggly top part, means approximately equal to. Now, we can work out 20 multiplied by 4, that's pretty easy. 20 multiplied by 4 is 80. So this is 80 divided by 0.8. Now, you should know from your work on fractions lower down the school that I can multiply this by 10 tenths to get rid of the decimal within the fraction. And this doesn't change it because 10 tenths is the same as 1. So I'm multiplying by 1 whole. And if you multiply by 1 whole, it doesn't change. If you multiply any number by 1, it doesn't change. So 80 divided by 0.8, that's the same as 800 divided by 8. These two things are the same. And 800 divided by 8 is 100. So my estimate, we know it's not exact, but my estimate is 100. Okay, let's have a look at some we do questions. So worked example 1, I'd like you to estimate each of those 3. So pause the video, have a go at those 3, and then I will do the solutions. Okay, hopefully you've attempted each of those questions. So I'm going to start off by saying that 17.2 multiplied by 52.3. So for my first number, I've got a number line that goes from from 10 to 20, because my first significant figure is 1. And 17.2 is bigger than the halfway mark, it's about here, so I'm going to use 20. For the second number, I'm using the 50 to help me round. This is lower than 55, so I'm going to use the 50. So this is approximately the same as 20 multiplied by 50, which is 1000. For the second question, again, it's 10, and this time we've got 3. I'll do this for the last question as well. So we've got the 6, the 100, and the 5 tenths. Okay, so for the first number here, my number line is going to go from 10 to 20. 15's in the middle, 80.3 is somewhere over here, so nearer to 20. 3.9, so I'm going to use 3 to 4. 3.5's in the middle, 3.9's nearer to that end, so I'll use 4. So this is approximately the same as 20 divided by 4, and 20 divided by 4 is 5. So there's my estimate. Okay, and for the last question, we've got 6 to 7. 6.5's in the middle, 6.4 slightly lower, so I'll use 6. 179.8, so I've got 100 and 200. 150's in the middle. This number is bigger than 150, so I'll be using 200. And for the last one, 0.5, 0.6, 0.55 is in the middle, 0.52 is less than that, so I'll be using 0.5. So this is approximately 6 multiplied by 200 divided by 0.5. 6 multiplied by 200 is 1,200. And like we did earlier, we can multiply this by 10/10 to get rid of the decimals. And 12,000 divided by 5 is 2,400. So my estimate is 2,400. Okay, here's another worked example. This one is fairly straightforward, but it's wordy, and so you have to read the words and pull out the key parts. Remember that, again, the word estimate is in the question. So they are not asking you to work out values based on 48.95 or 204. Pause the question and have a go at this. Okay, hopefully you've had a go at this question. If I was going to work this out exactly, it's going to cost £48.95 for each person that attends, and there's going to be 204 people. So the exact calculation is 48.95 multiplied by 204. That's how much it would cost to have the party. But we only want an estimate, so instead of using 48.95, I'm going to say, well, that's about there on the number line, so I'm going to use 50. And instead of using 204, rounding it to one significant figure, this is nearer to 200, so I'm going to use 200. And then 50 multiplied by 200, well, 5 multiplied by 200 is 1,000, but it was 50, so 10 times bigger, and this was a money amount, so I need to include my pound sign, so £10,000. Okay, the last worked example. Same sort of thing as before. We should work out what the actual calculation is first. So hiring coaches for 289 people costs £2,986.50. If the costs are shared equally, estimate how much each person should pay. So we need to share that cost out between all these people. So that's division. But we only want an estimate because the question says to estimate it. So instead of using these values, I'm going to use rounded values, and I'm going to round to one significant figure again. So halfway between these values is 2,500, and this value is about here on the number line. So I'm going to use 3,000. And for this one, I'm going to be between 200 and 300. 250 is in the middle, so I'll use 300 because it's bigger than 250. So it's 3,000 divided by 300, which is 10. So each person should pay around £10. Okay. So that is this video complete. You should now be able to attempt Hegarty task 131, and if it helps you, you could watch Mr. Hegarty's video first, but only do that as an unstuck. Good luck!